Now we are discussing the probabilities, right? And we discuss the experiment, sample space, event, and we take probabilities as based on the many kinds of the experiment, event, and is always is any kind of probabilities must be between 0 and 1. And sometimes we selected a card out of 52, and sometimes we made a Venn diagram. And in this example, we selected a student is out of 40. And last time we discussed the mutually exclusive. Can you remember the mutually exclusive? It is a very special case when we have the two separated circles on a Venn diagram, right? Yeah. So it was the mutually exclusive, and today, as we are going to discuss, is a little bit is more properties, the more rules. And anybody who has any questions? Is it today's homework? Yeah, I think it was not hard, right? Still, yeah, we are discussing the basic, is a concept of the probability. So even it takes just a second. Let me see. Go to the My Labs. I didn't post the new homework yet, but after class, immediately I will post the homework number 6. Number 5 is tonight, is due tonight, and it has only 6 questions, but absolutely you can finish up in an hour, right? Yeah. So if you didn't yet, yeah, please do the homework. It's tonight, and any question, email me. Okay, it's good. Okay, so today we are going to discuss the addition rule. It's actually, it will be a special one. We are going to have, we have 2 cases, right? One is the and the other one was the or. Today, we can apply addition rule when we need the probability A or B. We are going to have another rule for and later. So we are going to apply the addition rule. It's onto the or, but it is the special rule. So special case when they are mutually exclusive. So the mutually exclusive is a special case when we make the Venn diagram separately. Here is the A and there is the B. It's very special case. And we need the probability A or B. Can you remember where was or? You know, and was in the middle, but or we merged them together. But now they are mutually exclusive. So still, yeah, we just merge them together, right? So the probability A or B will be simply just add the individual probabilities because they are mutually exclusive. We are taking addition. So it has the title, the addition rule. But it is a special one. Why? Because only when they are mutually exclusive. So it is the special case for the probability A or B. Even we have another event, but they are mutually exclusive each other. Then additionally, A or B or C, then simply just add as one more individual probability, C, because they are mutually exclusive. So simply we just add up the probability of A, probability of B, and probability of C. So it is the special addition rule for the probability A or B. Now here is another rule. It's a complementation rule, but already we applied. So in this case, when I have an event E, it's inside, and the rectangle was the sample space, then outside was the not E. So if I want to know what is the probability inside, then it will be same as 1 minus the probability is not E. It is the complementation rule. The other way, probability is a not E outside, it will be 1 minus inside the probability of E. So it is the complementation rule. Basically it was from the idea probability E add probability of not E. How much do you expect? How much will be the sum of the two probabilities? It will be S 100%. Thank you. Yes. It will be S. See? E, not E, together, it will be the sample space. And the probability of the sample space, that will be 100%. Yes. Okay, let me ask you. Between E, not E, are they mutually exclusive? My question is, if they have any common area, it's between E, not E? No, they don't have any common areas. Just in the middle of the circle is the E, event of E. The other space outside, not E. They are mutually exclusive. So, exactly it is the right-hand side in the special addition rule. But when I take E or not E, merge them together, it will be same as sample space. And we apply the probability of the sample space, the rectangle, which was 1. So now I just subtract the second term as the probability of not E here, there. We can get the first one. Cancel out. Expectation of E will be 1 minus probability of the not E. If you want to get the second one, subtract the probability of E, subtract the probability of E, and cancel out. The probability of not E will be 1 minus the probability E. So, is there anyone will be true. But two of them, we can say it is the complementation rule. Already we applied the complementation rule before. See, when we try this example, one of them asks you, what is the probability of this? Simply, you suggest me 38 out of 40. From 40, subtract the two age group, 2 students. 40 minus 2. Already we applied the rule, the complementation rule before. So when we have an event inside, then simply we take the outside. If we knew outside, then by the complementation rule, we can take the probability of the inside. Okay? Okay, now here's another, it's an addition rule. So we are going to take the probability A or B again. But now it is the general one, in general. They don't have to be mutually exclusive. So let me make the Venn diagram. In general, here's the A, and here is the B. Still, we need the probability A or B. Before, Before, when we took the probability A or B, then we took the probability in the middle. I'm sorry, it must be number 2. And separately, we take the left one and right one. And we just add up, right? Good, right? But look at this. In the right-hand side, as a separately, we add probability of A and probability of B. It's like as the special addition rule. So when I take simply just add probability of A and probability of B, then it must be 1 plus 2. Yep, here. And the B, 2 plus and 3. How did I do? I added in the middle, number 2, twice. But the probability A or B, it must be A, I'm sorry, 1, 2, and 3. It's only single counts. In the left, number 1. In the middle, number 2. In the right, number 3. Only once. And then divided by is how many sample space, how many outcomes in the sample space, right? But now, simply we just add up the 2 probabilities. Then we added the number 2 in the middle twice. We have to delete one of them in the middle. How can we describe the probability in the middle? It was the probability A and B. So subtract probability A and B. It will be same as the probability A or B. In general, anytime, it will be true. So now, let me apply the general addition rule here. Yep. Select one card again out of 52. And here is the event of C. I will get spade. You know, the spade is another shape of the cards. It's out of 4. And D is a face card again. So let me take the probability of C. How many spades? 13, 13, 13, 13. So like as the heart, we have a 13, the shape, spade, out of 52. And it is one shape out of 4. How many face card? In each shape, we had 3 cards. J, Q, K. 3, 3, 3, 3. 12 out of 52. The other way I can interpret, we have 3 cards, J, Q, K, among the 13 in each shape. Is among the 13, we had the 3. The other 13, 3. The other 13, 3. So the simplified fraction will be 3 out of 13. This makes sense, right? Good. But now, if I want to get the C or D, or simply we can apply the general addition rule. So probability of C add probability of D individually, subtract probability of C and D. And already we took the individual probabilities. C was 13 out of 52. Let me use the probability out of 52 because finally we have to take the common denominator, right? So I just take the 13 out of 52, 12 out of 52. Just a second, let me see. C and D. When I make the Venn diagram, here is a C, here is the D, and C was the 13 space, and D was the 12 is a face card. You know, actually the C and the D, it must be in the middle, right? So how many cards in the middle? It's actually, it is the spade and face card. Spade 13 and face card J, Q, K of the spade, yeah, and in the middle there's a 3. So subtract the 3 out of 52. So 13 minus 3, 10, 12, 22 out of 52. That would be the answer for C or D. You know, before we got the general addition rule, we had 3 in the middle. Then how many on the left? You know, in C, it must be 13. So the remaining in the left must be 10. And how many in the right? 9. So we did, before the general addition rule, we take 10 in the left, 9 in the right, and we just add 10 plus 3 plus 9 out of 52. How many in the numerator? 22 again. Because 13 was 10 and 3. 12 was 3 and 9. We added 3 twice. So we have to delete. It's one of them. Yeah, it must be same. It must be same, right? But now we put the title, the general addition rule. For what? A or B. So please remember the or. For or, we apply the addition rule. And I said, anytime it will be true. Even when they are mutually exclusive. When they are mutually exclusive, A and B are as mutually exclusive. Absolutely, before we apply the special addition rule. But even we can apply the general addition rule. So please look at the general addition rule. When they are mutually exclusive, how much will be the probability A and B? You know, the mutually exclusive means the Venn diagram looks like this. We just put the 2 circles separately. And now, how much will be the probability A and B? It will be 0. Yes. Simply, I just delete. Because the last term, probability A and B, will be nothing. When they are mutually exclusive. So please now look at the general addition rule. It will be exactly the same as what? The special addition rule. So, you know the special one is a special one. So the special one, the general one, yeah, they are all addition rules. For what? Or. Okay, yeah. So please remember that. Any question? So far today we have 2 rules. One is the addition rule. But addition rule has 2 types, the special one and the general one. But it's totally the addition rule and the complementation rule. The inside, outside, outside, inside. Yes. Say again? Now look at the special addition rule. Okay, good. Yeah. This one? The other one, special. Oh, the special one? This one? Yeah. Yeah. The next one, the next topic will be two kinds of the probabilities. One will be the marginal probability, and the other one would be the joint probability. Okay. For the marginal probability and the joint probability, then we need the cross table. So I will show you the cross table, and based on the cross table, we can get the marginal probability and the joint probability. I will show you the pages later again. Look at this. We are going to discuss what? The joint probability and the marginal probability. And we have two categorical variables. The first one is the rank for the faculty members. It's a full professor, it's associate, assistant, instructor, and the other one is the age group. Basically the age is a numerical variable, but in this example, it's categorized. So now the variable age is a categorical variable. If I want to ask you, I'm 50. So if I want to ask you what is the proportion A4, the age group is A4, it's between 50 and 59. So I need the probability A4. So now from the table, how many faculties in the group A4? How many faculties? We have 253 faculties out of 1164. Does it make sense, right? Yeah. I need the proportion is how many is between 50 and 59. How many? 253 out of 1164. So that will be the probability. That will be the proportion. The other way, I'm an associate professor, associate, R2. How many faculties? How many associates? The other way, we have 381 associates out of 1164. So the proportion R2, we have 381 associate out of 1164. So now I just take the marginal totals to get the probability. We call this one, they are the marginal probabilities. Then now, how about this? I am 50 years old, the age group number 4, and associate. 50s and associate. How many? 50s and associate. In the middle, we have 68 faculties. We have 68 50s and associate out of 1164. Does it make sense? It is the joint probability. It's a joint one. So we joined together the two events, so it will be the joint. Then now, how about this? The probability A4, 50s, or R2. In this event, A4, 50s, or associate. They don't have to all associate because it is or. Among the 50s, they could be assistant. They could be full professors, right? The other way is among the associate professors. They don't have to be 50s. They could be 60 over, younger, it doesn't matter, right? But anyhow, we have an or now. Simply, I want to apply the general was probability of A4, 50s, add R2, associate, minus the joint probability A4 and R2. So separately, let me take the individual probabilities. A4, oh yeah, we took it. The probability of A4 was 253 out of 1164. R2, we got it. Add 381 out of 1164. And the joint probability, yes, we got it. Minus 68 out of 1164. We have common denominators because each marginal probability, joint probability, they are all is based on the same sample space. Always divided by 1164 divided by 1164. So simply just add up the 253 and 381 and subtract 68. We have a 566 out of 1164. It will be the probability A or B, A4 or R2 by the general addition rule. This makes sense, right? And also, can you understand how can you get the marginal probability? It's one way. It's a row-wise or column-wise. One way to get the marginal total. And the joint probability, yeah, the joint one, this one, and this one. Then based on the marginal probability and the joint probability, then we can apply the general addition rule is onto the probability A or B. Good, right? Fine. Any question? We can use the marginal probability and the joint probability even in the conditional probability. It's a conditional. The conditional probability is another kind of the probability. It will be the last topic. It's today. So the exam on Friday, the exam number 1 will cover the whole chapters 2 and 3, and chapter 4 up to the conditional probability. Okay, good. Okay, the last topic, the conditional. Let me see. You like play basketball? No. Yeah, you're a good player?
Not really.
Not really?
No.
Anybody who like play basketball? You? Okay, could you stand up?
Yeah.
Sit down, please. Tonight, we are going to play basketball. I and he. How do you think? Who's going to win?
I think he's gonna win.
He?
Yeah.
Why?
He's younger.
Yes, I'm 15. He's much younger than me. Yeah, younger. Yeah, why not? How do you think? Did you see him? Did you see him when he stand up?
No, I didn't.
Yeah, please on him. Yeah, please look at us. Right? Yeah. Sit down. Oh, yeah, I like that. How do you think? Who is going to win? Why? He said already younger. Yeah, and any other reason?
Did you say you like playing basketball?
He likes it. Oh yeah, I hate it. You know. How do you think? Who is going to win? Oh, he's taller. Yeah, absolutely. Yeah, the height is a very important factor. But at least you are taller than me. I think most of you is taller than me. I knew it. Yes. How do you think? Who is going to win? Oh, more athlete, right? Yeah. How do you think? How do you think? He, right? Yeah. Why? Any other reason?
I certainly practices a lot.
Oh yes, yes, yeah. Probably he likes the basketball. He did his more practice. My last game was when I was in junior high. Yeah, it's my friend is blocking me. It's after that is I never ever played the basketball. Yes, yes, yes. I agree. Yeah, he's going to win. He's younger. Yeah, I agree. And taller and more athlete, right? And yeah, whatever. You're gonna win. Yeah, I knew it. Yes. How about this? Tonight I will play with my friend. How do you think? Who's going to win? My friend.
But I didn't know who's your friend though.
Yeah, he didn't. He might be older than me, right? He might be shorter than me. You don't have any information of my friend, right? So probably you must guess 50-50. No information, no other condition. But when I play with him, yeah, you saw him, right? Yeah, it's a taller and younger, absolutely, right? It's more athlete, right? It's muscle and something, right? Yeah, I'm weak, he's going to win. See, when we have information, we have to use it. Before I just asked you, yeah, about the weather. Please look at outside. Sunshine, it is still hot, no rain. What do you expect tomorrow? Depends on when I see it today, we can expect tomorrow probably no rain, sunny, and hot. Depends on, see, right? That will be the conditional probability. So when we have any small information, we have to use it to get the better probability. So that will be the conditional probability, and later we are going to use the marginal probability and the joint probability again. So please look at this example. Here are the notations. For the conditional probability, we are going to use the bar in the middle, and we read it. It is the conditional probability B given A. Yeah, bar here. Yeah, we read the bar is given. So some other event A is given. It's something like the height, age, skill, athlete things, right? That will be given. And based on the given part, we are going to take the conditional probability. So please look at this example. We are rolling one die again. Then how many possible outcomes? We can consider 6 possible outcomes. Who are they? 6 possible outcomes. 1, 2, 3, 4, 5, or 6. Yes. In the sample space is 1, 2, 3, 4, 5, or 6. Now, the event of F, that is the event, I got 5. So what is the probability I will get 5? Or number 5? 1 out of 6. Yes. Here is the other one. O, odd numbers. Okay, it didn't ask us what is the probability O, but what is the chance I will get odd numbers? 3 out of 6. Odd numbers, 3. 1, 3, or 5. The 3 possible outcomes out of 6. Thank you. Okay, that is. But now, look at this. Now we need the conditional probability. I will get 5. But what is given? Odd numbers. So look at this. I'm so sorry. I didn't bring my dice today. I rolled in my hands. And I got something. And I told you I got odd numbers. I let you know. I got odd numbers. And now, what is the chance I got 5? 1 out of 3. How did you get 3? Because I told you, already I told you I got odd numbers. And now, how many possible outcomes? There's only 3 possible outcomes. Odd numbers, 1, 3, or 5. But what kind of probability do I need? I got 5. Is one of them. 1 out of 3. Yeah, 1 over 3. Yes. So the conditional probability, F given O, it will be 1 out of 3. Does it make sense? It's good, right? And how about this one then? I need the conditional probability. I got odd numbers, but I said it is not 5. Just a second. I rolled on me, and I got 1. I mean, not number 1, but I got something, right? And I told you it is not 5. Understand, right? So already you knew it. It is not 5. And now, what is the chance I got odd numbers? Just a second. Let me think one by one, right? When I told you I didn't get 5, yes. Huh?
2 cents. Well, you got odd, right?
Just a second. Okay, just a second. Yeah. But let me think it's one by one, right? When I told you I didn't get 5, then how many possible outcomes? 5. We have a 5 possible outcomes. Who are the 5s? 1, 2, 3, 4, 6. Not 5. I told you it's not 5, right? So in the denominator, how many possible outcomes? 5. 1, 2, 3, 4, and 6. Now, what would be the chance I got odd numbers? 2. Only 1 or 3. Who are they? 4 and 6. They are even numbers, right? So what would be the conditional probability I got odd numbers when I told you I didn't get 5? 2/5. 2 out of 5, yes. It will be 2 out of 5. So can you understand what is a conditional probability, right? The given part, already we knew it. So based on the given part, is already we knew it, we are going to take the new one. That will be the conditional probability. When I comparing the part B, part C, you know the part C is much harder. It's harder than part B, right? So it's sometimes it's confused. So we have a rule. Now we have a conditional, it's a probability, it's a rule here. When we need a conditional probability of B given A, then we take the probability A and B over the conditional probability A. I mean the given part, the given event is A. So let me go up. Let me try to apply the conditional probability in part B and part C. By the rule, it will be same as the joint probability F and O. Denominator, it must be the given event O. let me think separately. The joint probability F. What was the event of F? I get 5. And O, odd number among the 6. Right? Yeah. So how can I interpret 5 and odd number? You know the 5 is itself the odd number, right? So how many cases? 5 and odd number among the 6. There's only one case. The case of 5. Does it make sense, right? It's because the 5 is itself the odd number. So the joint probability F and O, 5 and odd number, there's only one case, the number 5 out of 6. Does it make sense? So in the numerator is up there. I just plug it's a 1 out of 6. Separately, let me think about the denominator. Yeah, please ignore the top one. Already we got it. And please focus on the denominator. It's odd numbers. How many odd numbers is out of 6? 3 odd numbers is out of 6, right? So the denominator, the probability of O, it will be 3 odd numbers is divided by 6. Always, we can delete the denominators. Because the joint probability, actually the top one, F and O, it is a joint probability. And the below one, the denominator, is the marginal probability. The joint probability and marginal probability, they are all based on the same sample space. So always we can cancel out the denominators. Then how much will the fraction then? It will be 1/3. Same. Let me apply the conditional probability one more time here, right? Just by the conditional probability, the joint probability O and is not F over, we need the given part. It's not F. It's not 5. Please think separately, okay? O, odd number, and not 5. How many numbers? How many odd numbers? Not 5. Only 2. Who are they? 1 and 3. So the joint probability O, odd number, and not 5, the joint probability will be only 2 out of 6. It will be only 2 out of 6. Then now, please look at the denominator. The denominator is not 5. How many numbers? Not 5. 5 numbers. 1, 2, 3, 4, and 6 out of 6. 5 out of 6. I told you, always we can cancel out the denominators. And now, in the left, by the conditional probability rule, the fraction will be 2 out of 5. It will be same. So either way, you can take the conditional probability, but instinctively, this way, sometimes it's confused. But strongly I suggest to you, please apply the conditional as a probability rule. In the rule, separately, you can take the joint probability and the marginal probability and take the ratio. Always, you can cancel out the denominators. We are going to review on Wednesday. And here is a quiz number 6, please.
Last year, training.
Anybody who didn't get back your keys? How many full professors? Full professors is marginally 430 out of 1164. Yeah. And now here's the end. This part B is the joint probability, right? And full professor and over 60. How many? 75. Jointly 75 out of 1164. And now in part C, here's the or. Or. Apply the general addition rule. Can you remember the general addition rule? Which was full professors R1 or A5. So we just add R1 individually A5 and minus probability R1 and A5. And now finally A5 given R1. Then by the conditional probability rule, it will be same as A5 and R1 over the given event, R1. Do you have an idea? Any question, ask me. I can help you.
Yeah.
Please make sure your schedule.
Yeah.
Please email me. So we can make a phone call. We can take it Wednesday afternoon.
Okay, yeah. Oh, thank you.
Yes. See, the probability of full professor plus probability over 60 and minus probability full and over 60, the joint probability. And now the full professor we got here, good, and over 60 here, I'm sorry, over 60, you have to take the over 60. How many? Marginally 60 and over? No. Marginally at the end of the right end. 90, 93, right? Yeah. So you add 93 out of 1164. And then subtract 8. Does it make sense, right? Yeah. So what? So you have to apply the general addition rule first, and then plug into one by one. Yes.
What is A5?
A5. I'm so sorry, I made the table smaller. Yeah, here is the event of A5, the age group number 5. It's over 60 and over. It's over. I'm so sorry, it's
So is
over.
is it all of those?
Do you need the probability of A5? It is a marginal probability, the marginal one. So the second probability A5 marginally, it must be 93 out of 1164. So already we take the AR1 in part A. It was 430 out of 1164. Additionally, another marginal probability of the 60 and over 93 out of 1164 minus we got the joint probability in part B. How much was the joint probability? Full and over 60. 75 is out of 1164, right? Just a second. P is a conditional probability. P is the conditional probability of A5 given R1. Then I, the conditional probability rule, it will be A5 and R1 over the marginal probability of R1. Yes. Oh, Professor. Yes. Last part is the conditional probability. Is over 60 given the full professor. And simplify the conditional probability rule. We need the joint probability A5 and R1 and over the given event. What was your question? You got it? On B, and we need, yeah, it is. So how much was the joint probability? The joint probability, right? That was 75 over 1164. And did you get this one before? Yes.
Okay, so for this one, I think I said that right, but no.
Before apply the numbers,
Okay.
it will be same as probability over 60 and full professor
Okay.
over the given probability of the full. Okay, now, did you get this joint probability is over 60 and full?
Yeah, it's 75.
5, so it is a 75 over 1164.
Okay.
And separately, did you get the probability of the full professor before?
430, right?
430, out of 1164. I told you always we can cancel out. And finally, the fraction will be this.
Got it.
Yeah.
Okay, thank you.
Yes.
Is it smart number?
You're right.
Oh,
Yeah, good. Yes. R1. What was R1? R1 was the full professor. And you need a marginal probability. 430 out of 1160. So at the bottom, 430, then we can cancel out the denominator. And the fraction will be the conditional probability. No, you don't have to keep the addition, alright?
So it's.
How much would be the joint
So
probability?
the whole thing over.
It's over 60 and full professor.
Let me see that.
You got it somewhere. The joint probability.
oh,
75.
oh, okay.
The joint one is 75 out of 1164. Separately, what was the probability? Yes, yes.
Oh,
So take the fraction of the fractions
yeah.
and cancel out the denominators. The remaining fractions will be the conditional probability.
Oh.
Yeah. Because, I'm so sorry. You have to apply, already you applied the conditional probability. Right? So, separately, can you give me the joint probability?
I know.
The joint probability over 60 and the full professor 75 out of 1160.
We're ready to eat contract.
Because we need the denominator later at the bottom. So on the top is a 75 out of 1160. Separate. What is the proportion was the full professor? This is 430 out of
I'm a little worried.
430 over 1164, but we cancel out the denominators. The remaining fractions will be the conditional probability. Yes. You don't have to do that, but it is better. Yes. Email me. Absolutely, you can take the example. Email me. Please thank you, and please email me.
Yes, we will.
See, we have some rules. So any problem, we have to apply the rules. So you have to copy the rules, and then you plug into the rules one by one. And then math. Before the math, you apply the rules first.
Okay. Thank you. So where, we are reviewing Wednesday?
Wednesday, and we are going to take the exam on Friday.
Okay. I can give.
Have a good day.
Bye.